ACI system. Right now, we're kind of just in the talking to folks and getting an idea of what system will be best for us before we make any sort of selection on that Sorbent trap system.
Okay, fantastic, fantastic. So now, obviously, you guys have the one-year extension and will be looking at compliance of April next year, correct?
That is correct.
Okay, and then how many systems will you guys be looking for?
We'll be looking for one here at the plant, and we're probably also going to have to put in a continuous moisture monitoring system due to the moisture content.
Okay.
We're way above the default, EPA default value.
You're way above that, okay.
Yeah.
Okay. And kind of on a sidetrack, seems you brought up the topic, and just to let you know, and Chris can show you this a little bit later, that our system per PS12B is a closed system. So we actually collect the moisture content from the gas stream that we're sampling. We have petitioned the EPA to be able to do a gravimetric method 4 on that moisture that we've collected. They've gone ahead and approved that for 30B. Testing, and we're still petitioning them to go ahead and do PS12B testing. So depending on the time frame that the EPA is working on, I know they're completely understaffed right now, but there is a possibility of them approving that, and you guys could actually do your method for doing a gravimetric from the moisture we collect. So we don't have an answer for you right now, but that's something that might be possible moving forward in the future.
So I would be using that. If they okay that petition, then you're saying that when we test under method 4, that's the value we use for moisture?
Exactly. You could do a gravimetric test on method 4 from the moisture that's collected during, say, if you do a 7-day sample run. We have moisture knockout bottles in our system that will collect that the moisture that we've removed from our gas conditioning system, and you'd be able to use that instead of a secondary device or your default value to do a gravimetric method 4 and report the actual value that way. So we're hoping the EPA will go ahead and approve that for us, and as I said, we're still petitioning them. We saw them last week out at SES conference in Arizona. I know they're very understaffed right now, but they're actually looking to bring on 2 more people in the next couple of weeks, so hopefully that will help us expedite this process for us. So we'd be happy to keep you guys updated on developments that happen there.
Yeah, that'd be great if you keep us informed on that.
Yeah, because if we can have that, again, as I said, it would save you guys either buying another device or using the default value. So it'd be great for everybody.
Yeah. If I use the default, I'll be reporting.
What's that, mate?
I said if I use the default, I'll be over-reporting.
Yeah, right. Absolutely. Absolutely. So we'll definitely keep it there. So, so are you guys very familiar with our systems? We can run through a couple of things, how familiar you are with PS12B, the kind of things you guys would like us to touch on today.
Yeah, you can go ahead and run through it.
Okay. Okay. What I'll do is I'll pass you over to Chris. He'll start. What we'll do is we'll go through a little bit of 30B, PS12B for you guys, just to get you up to speed on the basics of the legislation. Then we'll touch on our Sorbent trap system and what we offer, and then hopefully David will be joining us by that stage. And what we can do is we can run through the software that comes with our system and give you guys kind of a brief overview on how you interact with our system, how you pull out the reporting data, and all those types of things. So just feel free to jump in anytime, guys, if you've got questions, things like that. We'll make this real informal, since there's only a couple of us on the call today.
Okay.
Okay. Okay. Hi again, guys. It's Chris here. probably what you'll find is I'm going to, oh, where have we gone? I'll probably cover some ground which you're probably quite familiar with anyway, but you know, by all means, just you know, ask me questions, ask questions as we go through. Oops. There we go. So yeah, I'm going to touch a little bit on the 30B system and then our XC6000, and then we've repackaged that device and we can now call it the STM12B. It functions exactly the same as our piece of kit that we've had around for about 8 years. We've just managed to put it into a smaller footprint box, which we knew last year a few people were asking us, could we do that? So you'll see that a little bit later on. Just a little bit about the product, our sorbent trap monitoring systems. We've got just over 300 of them installed in the United States. And it's been around for about 8 years. So we've got quite a lot of them in the power industry, electricity generated, some in cement and 1 or 2 other applications. But that gives you a rough map of where a lot of them are. Sorbent trap monitoring, it captures the total vapor phase of mercury concentration in the flue gas. And then it's analysed independently, and you get a measurement in micrograms per dry standard meter. The 30B technique is the reference method developed by the EPA for relative accuracy test orbits, the RATAs. And it can be used for proving compliance for a mercury SEMS or for the continuous sorbent trap system. Generally, it's intended for use under relatively low particulate conditions. And when you do the RATA, it's recommended, or in fact I think it's mandatory now, that you use the same carbon in the traps for the 30B as you do for the continuous sorbent trap analyzer. Quite simply, you know, known volumes of gas are extracted from the stack in paired sorbent trap media at an appropriate flow rate. For PS12B, this is always at plus or minus 25% of the stack gas flow. One of the nice things, of course, is that the collection of mercury is on the sorbent media, and therefore you're not transporting mercury down a sample line. It's collected in the stack. This is taken directly from the standard, a representation of the 2 traps at the end of the probe. We're pulling gas through here, and then all we're doing is really we're measuring the volume of gas during the whole of the sampling period. Quickly, a difference between a 30B and a PS12B. The PS12B is the device that's used for long-term continuous sampling. The standard mentions that you can sample for up to 14 days. In reality, most people change the traps after 7 days. The 30B system is for the short-term sampling. But it's relatively the same type of device, a control console, something to knock the moisture out, the probe going into the stack, and then transporting the gas through the system. I'm going to skip over that on the 30B. The sorbent trap monitoring system has to be operated and maintained in accordance with the specification 12B. And it gives you a detailed table of what you've got to do. Like I mentioned, it can be used for up to 14 days, but that would be really dependent upon how much particulate you've got in the stack. A couple of slides I'm going to quickly click over here and take you into our 12B system. And we put this phrase in simple proven technology. We've been manufacturing isokinetic sampling apparatus for about 28 years. And we've really taken the same sort of functionality and built it into this sampler. We have the dual paired control system. We can monitor what amount of gas is being sampled at any time. We have a closed moisture knockout system. And then the device is housed in a 20U cabinet with its own heating and air conditioning system. And then we access to be able to get the test data via a laptop. Relatively simple package, one that we've had around for a long time. Obviously components do change, but we always look to improve the components when we have to make a change. Sorbent trap monitoring, of course, for compliance reporting is a much simpler alternative to continuous analyzers to keep them within calibration. The sorbent trap measurement is a manual technique that takes time-integrated mercury sampling, and as I mentioned previously, typically for 7 days. Although within the profile, we'd recommend that you make the profile to sample for about 10 days, just in case you can't get back to change the traps. The sample, of course, is then analysed in an analysis which you might do on site. And then the concentration is equal to the mass of mercury collected divided by the volume. Oops, back to that one. Some of the advantages of the sorbent trap monitoring, it's really simple and easy to install, implement and operate. Typically it takes us no longer than a day to get it in, up and running, and even train the people. It's a very accurate method. The cost benefit is really significant to the use of a continuous analyzer. A typical package is round about $50,000. And of course it has a long history within the power and coal utility industry. You've got that significant feature there. There's no mercury transport issues, no mercury is lost because it's collected on the traps. And there's little or no stack facility engineering costs, and of course we don't need calibration gas. I'm going to have a quick look at the traps. Oh, I think these slides have got a little bit confused, or my notes have got confused. Our XE6000 mercury monitor, we have a heated sample probe. The traps are inserted at the end of the probe, as we can see here. The gas is then transported down through the system, and then we knock out the moisture. We knock out the moisture using a Stirling gas cooler, which I'll talk about a little bit later. And then really we're just recording the volume of gas throughout the sampling period. All the temperature measurements, temperature controls, we have opto-isolated thermocouple measurement within our MUX board, and then we have high integrity data capture. The data capture is embedded within the software, within the control console itself. Additionally, we're constantly writing to an SD card. So if anything should fall over, we've always got the information ready to be downloaded. The traps themselves, the mercury that we'll see in the stack, we capture on this first bed of carbon. This second bed is analysed for breakthrough, and the QA/QC procedures from the standard dictate that it has to be less than 5% of section 1. This third section, again, it's a QA/QC check. So this is spiked to an amount of mercury that we'll see within the stack. And so now the spike recovery must adhere to what's required by the standard. So that's what a PS12B trap will look for. So each section is analysed separately. The total mass of mercury measured is determined by section 1 and section 2, and then that section 3 spike must be recovered, and it must be within those QA controls. Your initial certification of the system, you must have a router against an HGE reference method, and it dictates within the standard all the control parameters that you need to pass. During the sample run, the first thing that we have to do is to ensure that we do a leak check before starting to sample, and we do a leak check afterwards as well. The pre-leak check will be at a vacuum of typically around about 15 inches of mercury. And then the post-leak sample will just be at the highest mercury that the device has seen, the highest vacuum that it's seen throughout the sampling period. When we look at, oops, go back again. When we look at the device, the sample probe going into the stack, typically through a 4-inch or a 6-inch flange with a cam lock to enable quick and easy removal of the probe and quick and easy changing of the traps at the end of the test. And then we have this junction box at the end with the interface with the umbilical. I'm just going to skip over some of these slides. We can go back to them a little bit later. But the traps are easily inserted into the end of the probe. Inside this compression fitting, we have a glass-filled Teflon ferrule, which we recommend not to tighten down too hard. Once the ferrule grips, you should only need about a quarter of a turn with a wrench on the nut to ensure that it is leak-free. Of course, sometimes we do come across quite challenging sources and environments. In this instance, obviously trap configuration, the profile temperatures are important to the success of the sampling, and especially for a 7-day period. One of the things that we can recommend is, of course, the use of trap shields. We use this double nut configuration. Once we've done the leak check and we've not interfered with the traps, we can now place the trap shield into the double nut, and then it's protecting the trap during the test. So it's always dual trap sampling, it's always a dual trap probe, and then of course with trap protection as well. The sampling profile can also be written to ensure that we can sample for up to 7 days, making sure that if the stack is particularly wet, getting the trap temperature up to a relatively high temperature to make sure we flash off that moisture. I mentioned the Stirling cooler. One of the reasons we chose the Stirling cooler is really for its ability to work in extreme ambient temperatures. It's a very simple device where it's just compressing helium. This chunk of metal at the end gets nice and cold, and we have to control the temperature of that. We have to heat it. We actually got the technology from organ transplant conditions where they needed a very reliable cooler. We use the same cooler, and we don't get a lot of problems with these coolers on the installations. So there we are, the 20U cabinet, all self-contained, and that's our most common installations. But we did come up with this redesign of what we call the STM12B, where we repackaged the cabinet to put it into a smaller footprint. It's shown a little bit clearer there. We actually ship it like this on its own stand, and therefore when it arrives to you, if you choose this configuration, you've got a stand for the device instantly. One of the things about that, of course, everything is self-contained in its own box, and we also put in this touchscreen interface as well. Quite a nice feature. When you're up there, you don't need the separate laptop. And you can access all this information that's going on anywhere over the plant network. The STM12B, of course, though, has exactly the same functionality as the XC6000. They operate completely the same. One of the advantages you've got with it, of course, you've got this swing-out panel where you can actually see the control board at the back and the dry gas meters. The knockout bottles are a little bit smaller, and the chiller itself is a little bit smaller than the conventional Stirling gas cooler. Typically, the configuration is for everything to be up on the stack, all closely connected, and then just with data information coming down over the plant network into your plant data acquisition system. How the XE6000 looks, a typical installation, generally quite close to the sample port. We do offer a number of different configurations. That one we've just shown with everything up on the stack. A second one where we put the probe up on the stack and then the cooler, and then we transport the gas down to the console, which might be in the SEM shack. And then the third configuration, this is more common within the cement industry where they don't normally have stacks which are capable to handle the size of the console. So the Mercury sampler console, there are some of the features of what's contained in there. At this stage, I'm going to hand you over to David Allen, who's one of our senior technicians in the technical support group, and he'll take you through the software.
Okay, that's not a problem.
Should have all the slides for you if you like.
Yeah, so she's live.
You guys got any questions about the hardware or anything first before we move on to the software?
A couple quick things. Do you guys have variable NEMA designations on your cabinets?
NEMA designations?
NEMA
4.
NEMA 4 is normal.
Cool. The other thing is, what are your guys' power requirements up at the stack? If we were to have a full system up there.
Yeah, we require 215 volt circuits that are rated up to 15
About 15 amps, yeah.
15 amps? Okay. That's
Oh, I have one too. On the communication line going down to the gas, what protocols do you use are available?
Normally we send everything down as a Modbus package. And yeah, typically either Ethernet or via a fiber.
Keep going, CR1. Through fiber.
I'm sorry, I missed that one.
Typically, you would have an Ethernet cable coming from the instrument to a media converter, and then fiber down the stack, and then to another media converter, and then to a switch, and so forth onto your DAS. That's a fairly typical network configuration.
okay. Does Apex have any specific media converter for them? I know a lot of other SEMS type folks recommend their proprietary media converter.
Generally, no. We normally, that's your choice really, because you've probably got several.
I mean, what you see commonly is the black box version as the media converter. That's the most typical one. I know we don't have any issues with that one. That it, seems to work fine. I mean, it's pretty straightforward. Yeah, you give us your IT department would assign you a IIP for the instrument. We would put it in the instrument for you, verify that it can communicate at the rear of the instrument, and then your contractor would, typically bring up your fiber and your media converter, and we would, provide that connection to it. And then downstairs, you could always install the software on a server and also access the instrument. If you just wanted to view what's going on, you could actually use our software to view it. You could export it during its operation too, and also, the data is also being brought into the DAS at the same time. And it's very versatile about, communication-wise, IOs. You can use Modbus to talk to it, and at the same time provide an analog 420 if you so choose, or a flow, or a pause for like the boiler. But the same thing is capable via the Modbus too. So it's very versatile on the IOs and the communication side of it.
Okay. And then like alarm statusing and whatnot, I'm assuming that's available for like the AC system and whatnot.
It is. I mean, you got choices there. Also, it's very versatile on the alarm. We have many alarms in the system and many conditions. If you're doing the Modbus, it's more specific alarm-wise. Now, we do have an analog that's a general alarm IO out of the rear also that you can use. You can do it multiple ways. You can configure that analog one to, close a relay, maybe cause a flashing strobe light to go off, or, a buzzer, or even just a closure of a contact to let something, at the DAS, let the DAS know that, there's an alarm. But it's a general if you use that one. If you use it straight up with the Modbus, it's more specific, as in I've got a high vac alarm, or I've got an out of tolerance with proportional sampling, or whatever. It's actually very more specific. You get a lot more information through the Modbus.
Okay. And also for identification and monitoring plan on your sample flow meters, your dual meters, do you have separate identifications for those?
Okay, I think I understood what you're saying. Yeah, the mechanical gas meter internally, they each have their own serial number, and that's also in the data. That will also be in the data exported, and it's also in the data for the quarterly audit that's produced also.
Okay, that's what I was looking for.
So basically it's very easy to identify what we call A side and B side, and see where you may have issues with either vacuums on a particular side, gas meter readings, those types of things. We can pretty quickly identify if we're having an issue on a side, which one it is, and start problem solving from there.
Okay. And the alarm code is very simple. It's a very simple key. It's the alphabet, ABC, and each one of those letters indicate an individual alarm, and what is the action of that alarm. So that's all in the CSV file, but it's also, it flashes on the screen, if you were looking at it in real time, and so, like I said, it's very versatile.
Okay.
Just going back and confirm, guys, you guys would most likely be looking at this configuration one where you have everything up on at the stack location and bringing that communication cable down to a SEM shelter or wherever you have your DAS. Is that correct?
That's correct.
Okay, perfect. All right. Great. Well, maybe we'll have Dave walk you through maybe a little bit more of the software and show you some of the features and things like that, and what we have available.
Okay, good.
Yeah, I'll just click through once you.
Okay, so this is the main connection screen here, and when you click the little red icon to bring the software up, you're going to first have to connect to it, and that would be on the left-hand side down at the bottom, typically. And you just click connect, and it goes through a small process. It always remembers the last test that was being run, the profile that was being used. So you've always got one internally. We use kind of a little standardization of you notice it's kind of a fluorescent green. That's kind of like the indication of what's next to come. So once you set up a profile, and let's see here's the typical layout. So connection is the first screen up at the top. The next one would be the alarm screen where you would choose alarms. And actually that's not the right order. Process, yeah. So the first one's the connection, the one on the right next to it, that would be your pre-leak test. Because you've got to do a pre and a post leak when you run these tests on the system. And then the next one down here below the connection screen is the alarm, where you would choose your alarms. And the alarms have a couple of statuses there. You can disable it. You can choose it to alert. You can choose it to pause the test. And you can choose it to end the test, typically. The next following screen below that that's the test setup screen. This is where you're going to choose your duration, how you want to sample. You also got that normally open and normally closed contact right there in the middle of the screen, sort of. That is for if you want to send like a boiler, boiler's on, boiler off type condition. So we'll pause the system. You can do it. That's for the analog side of it. And then of course you choose, your proportional. If you're going to do constant, you got a little drop-down menu there to choose from, and then you can do 1 to 10 volts, 4 to 20, or you can do Modbus as far as your proportional. The continuous is for constant is fairly straightforward. You just choose constant, and you can, for reference, you can choose, your acronym for, your stack flood. You're going to do KSCFM or whatever you want to use there. And that is only stamped into the data. There's no calculation done with that at that point. On the right-hand side of that screen, you have a choice of if you're going to give it a moisture signal. Now, you can give it a fixed value, and that's probably the more common process. But some plants do have a moisture monitor, and they will provide a moisture signal. And again, you've got options there. You can do 4 to 20, 1 to 10 volts, or via Modbus. So, and you choose your flow rate too, also on the screen here. We can sample down as low as 250 cc's a minute, and that's the main thought is you want to kind of sample as low and slow as possible. That gives you the longest duration. Most plants will set a profile up to run for 10 days with the intent of changing the traps about every 7 days. But stack conditions, are different in every stack. So, I mean, you got to do a little, when you first bring the system in and start running, it's like a little mini trial, you kind of filling out the conditions and how long you can run. But typically it's about 7 days. And then we also have that last screen there.
Calibrations. That Delta P.
Yeah, that's from the calibration. That's just a snapshot of the calibration screen 2, where you can actually tweak your heater profiles. We have standard heater probes that we use currently, and you've got a 6, a 9, and a 12. But we also can do custom links. And if we do custom links, then of course we may have to tweak the heater profile. It works more like a PID loop scenario. And also there's where you cal your baro, and also your, what is that, the 4020? The 4020 is also caled there, and the 1 to 10 volts also. That's just a snapshot, though, of cal screen 2. Now this is where it gets down. This would be after you connected. This would be setting up a profile. Here, this is for informational purposes only. All this information will be transferred to the exported data file, the Apex exported data file. So no calculation is done. It's just, like I said, informational purposes. And that will be up to the plant or the environmental director at the plant to decide what information he would like to be put in here at this time. Okay, so the top screen is the pre-leak check. It's independent, and you're going to choose start on the A channel and then choose start on the B channel, and it automatically is going to pull max back and no flow, and it does a calculation, which I believe is 4%, to determine whether it passes or not. It usually takes about, depending on how long the train is, if it's going up down the stack, it takes about a minute to a couple of minutes, depending on, like I said, the configuration that the customer has purchased. And like I said, once it's passed, it gives you the all clear to go ahead and proceed. Personally, I like to see, when I do a leak check, the best result possible. So if I do have a small leak, it's typically where I've been breaking the connections at the trap or possibly at the condensation collection vessels in the system. So I'm going to go back and double check those and make sure. But I like to see, the best leak check I can get. And typical results is 0 to 2 cc's. That would probably be the most typical. Okay, so here's the monitor and run screen. Here you can see all the temperatures, the internal, the stack. We'll start at the top here. So you got the stack, the probe, and the trap, and the aux. The aux would be the heated umbilical between the probe and the system. And then, of course, you got an internal monitoring. You got individual DGMs. You can see these are all live values in real time. You can see the amount of vacuum that each system has currently on it. You can see the flow rate, what its targeted value is and what it is. And you can also see the DGM values down there of what the volumes are. This volume will be in the data, exported data file, and all of those temps too. Post-leak check. Post-leak check at the end of the test, of course, you're going to pull the highest vacuum seen during the run. It's pretty straightforward. It's monitoring and doing the mathematics and calculation of what the method requires for it to pass. At minimum, it will pull 5 inches. Other than that, it's going to pull whatever was the highest vacuum seen during the actual test. But it is very similar to the pre-leak test. This is a typical exported CSV file for the data run. So you've got all your, these are 1 minute data points, which we have many. You can choose 1 minute, you can choose 5 minutes, 10, 15. You have quite a variation on how many data points you want. I recommend 1 minute data points because the way our system is designed, we have an internal SD card. It's capable of collecting 99 runs, and each one of those runs could be 30 days long, and it still would have room. So the reason I recommend 1 minute data points is that it gives you more resolution. You can see what's going on prior, if you have an issue, or if stack conditions change. So it gives you a lot more resolution of the test during the run. But as you can see, this is your TCs here starting, and then we have our corrected volume. And then we have our mass flow target, and the top line, very top line, right underneath each acronym for each one of the channels, that's the average for the run. And then, of course, you got corrected volume on the right, and it's just out of view. You can't quite see it here. I can't quite see it here, but it also tells you what proportion, how close to proportional sampling you are during that time, what the percentage of the valve is open. Quite a lot of information here, and this is just the upper half. Down below we see more of the test parameters. Yeah, we may not have that in there. So it's pretty straightforward. Leak checks pre and post, plus or minus 4, 25%, very generous on the proportional sampling. The ratio, stack flow, traps. It's a fairly simple system that really, the learning curve is very, very quick on it. It's not overly complicated once you quite get a grasp for how it's set up. And you can save profiles. Some plants have profiles, proportional sampling. If you're in the north or in the south where you have, in the wintertime, we're at base load. And then maybe in the spring we're not. They may have a profile for the proportional they'll use during those cold months, and then they may have one they may use during the months when the demand's maybe not quite at base load. So, you guys got any questions?
Yeah, on the calibration audits, is there any special equipment our technicians would need for that?
There is actually. We have a audit kit, which is running around about $2,000, I think, at the moment. We're in the process of switching it over. So previously we used to use a dry gas meter with a 15-point calibration on it. We're actually switching to a new device called an AliCat. Basically, it's a handheld mass flow sensor. And we're actually in the process of updating the software at the moment right now as well. So it's going to hopefully be a one-touch automation process where you'll take the AliCat device, you'll hook it up to our Sorbent trap system. On the audit screen, there's going to be just basically an audit button that you hit run, and it's going to go through and do the calculations for you. And all you'll need to do is plug in some of the values that you're reading off the AliCat. So that is the device that you're going to need to do your quarterly audits with. It comes with a couple of other devices that you'll need for calibrating your TCs and various other things that the method requires you to do on a monthly basis. A quarterly basis, sorry. And then provided you pass your quarterly audits every single time, there's no need for recalibration of the device at all.
And does that require an NIST trace periodically?
Right. It's a NIST traceable device. The only thing you'll have to do is send the AliCat device back to AliCat in Tucson, Arizona once a year for verification.
Oh, okay. All right.
Yeah, typically that quarterly audit, once you get used to it, takes about 1 hour.
And one person can perform it. So
Yeah. So that would be about 1 hour, and would you say once a week changing the traps is about 15 minutes once you get into it? Once you get pretty proficient at doing it, it'd be about 15 minutes for a guy to get up on the stack, do his post-leak, change out the traps, do the pre-leak check, stick the probe back in, hit sample.
Depending on how tall the stack is. Some of it's about a 7-minute ride up and a 7-minute ride down.
You got 1 minute.
You got 1 minute to change the traps. Yeah.
And what's the cost for your traps?
About 100. So traps are around 100 each, and then have you guys made any decisions on how you're going to do analysis?
Still up in the air on that. Working with our central lab group to see if we want to just buy one for our fleet.
Okay. Yeah. So obviously, I heard Lumex right now offer the analyzer if you guys want to buy that. The other option, we do have a lab here that can offer that service as well. All you guys would do is send the traps back in with the run data, and then we'd do the analysis for you, and then and send you a report. Typically, turnaround right now on that once we receive the traps about 2 to 3 days at this point in time.
So what's your cost for analysis?
Analysis is $120 per trap. And I couldn't speak to what the cost of the high Lumex unit is. I'm not really sure.
I'm just putting numbers together.
So as far as the actual traps themselves, are you guys open to any sort of trap? I mean, we've had a lot of discussions with Ohio Lumex, and I think Hawthorne's going Ohio Lumex for their actual traps.
Right. And I mean, we have different customers using different traps. We have some customers using ours, some using Lumex, some using Frontier, isn't it? Yeah. So our device will take all traps. It's pretty much a standard size.
10 millimeter.
Yeah, 10 millimeter traps. So we got no problems in taking that now. And you guys think you'll be using a standard trap? You guys don't have any high acid gas concerns or anything in particular from your stack gas composition?
No, there's nothing grossly unusual about our flue gas.
Okay. You'd be just using a standard 3-bed trap, so that's no problem at all. Now, would you guys be looking at purchasing a 30B system for router testing, or are you guys trying to bring outside help in for that type of situation?
I think we're blessed enough with a lot of local groups out here that would have that sampling system, so we wouldn't have to purchase one.
Okay.
Sure.
Yeah, no problem. And you know, we have a lot of stack sampling clients that use our 30B system. I just wanted to mention it because we've kind of had a mix of some guys have in-house teams and they've bought both systems to be able to do that internally. But as I said, then again, yeah, we do have a lot of customers offering that service as well. So
okay.
Just keep that in mind. You'll have that expense as well.
Yeah, the one thing that would be critical for me is to figure out the moisture situation, because if EPA is late on that, we will have to install a separate system.
Right, right. And again, what I'll do for you guys, I'll reach out and see if they've made any decisions on PS12B for gravimetric on those bottle collections, and see if I can get an update for you.
What's your lead time on your continuous moisture system?
You mean the Sorbent trap system?
No, if I have to put a moisture system in, I have a quote from you guys on continuous moisture. If I had to put them in, what would the lead time be?
Yeah, we don't obviously manufacture them ourselves. We have a couple of vendors that we can partner with to do that, and I think they're on about a 6 to 8 week lead time. I'd say we could probably do it in fairly close conjunction with the delivery of the sorbent trap system.
Okay.
Yeah, Mac is the most common one, and we have a relationship with them.
Okay.
Is there anything else we can answer for you guys, cover, anything outline that you guys can think of right now?
No?
No, I think we're good.
Yeah.
Cool, cool. So just one more thing. We kind of touched on this earlier, but Chris kind of mentioned that typically when we package these up, we will get requests for training and things like that. I mean, if you guys are used to running SEMs and all those other types of equipment, this is really quite easy compared to that. So typically we'll see maybe a 2-day visit to site for you guys. We'll come out, we'll pretty much do kind of some classroom training and go through some things on day 1. Day 2, we'll get up on the stack, we'll set up a profile, we'll run through some tests and make sure the guys are familiar. We've never really had a client that needed to run any longer than 2 days to get familiar with the system. So
it's a hands-on training class.
Dave runs a hands-on training class and gets everyone in there and learn the system. So, and typically too, we can if you guys had the unit up at the stack elevation within those 2 days, Dave can make sure that everything's communicated, working, hooked up to Modbus, all those types of things as well. So, unless there's anything completely out of the ordinary or not working right, 2 days is typically more than enough.
Yep.
Do you know what your stack temp is, guys?
Somewhere between 240 and 270 typically.
Okay.
Okay.
All right.
Yeah, Jared, Marty, I know you mentioned when we first spoke about possibly me coming out and seeing this equipment. If you'd still like that, don't hesitate to give us a shout. And I've got a couple of trips coming up, and I could probably fit you in sometime in the next few weeks if you'd like me to come to site.
Okay.
Okay.
Yeah. So you guys were thinking maybe late summer. You'd be looking at putting the sorbent trap in to be ready for the SEMS units by fall. Was that correct?
Warehouse P2, please.
Yeah,
What's that again, Martin?
Time frame.
Yep. The approximate, yeah.
Yeah, okay, and that's fine with us, no problem. I mean, we're keeping pretty busy on the stuff, but we've got our production teams building a couple to stock. So, you know, the only real variables we'd have to decide on once you guys make a decision if you're going to go with the Apex system would be probe length, umbilical length, and that's kind of about it. So we could discuss that at a future date.
And that's your system is about 8 week lead time too.
Yeah, 6 to 8 typically right now. Because I got them on the shelf, we could do about 6 weeks actually right now. So then it would just be a matter of deciding when either David or Chris would be available to come out and do the training for you guys as well, based on their schedules.
Okay.
You guys think you'd be around about a 6-foot probe? You need to be 1 meter within inside that stack wall. Do you guys have any other challenges in terms of flange lengths or anything that would prevent you from using a 6 and have to go to anything longer?
No.
Okay. That's typically kind of the configuration that we'll do. We'll do a 6-foot dual-heated Hastelloy probe with about a 20-foot umbilical, just to run from there over to the device. So that seems like you guys are pretty much a stock standard kind of system. So that's pretty easy.
Yeah, say goodbye, P2.
Okay.
All right. Anything else you guys want to offer? Sounds good.
If you need anything else, guys, just give us a shout.
If you have any technical questions, just call the technical services group, and any one of us will be in that group. We'll be glad to try to help answer any technical questions you guys have. So.
Okay. Sounds good.
All right. Thanks for your time, gentlemen. We'll touch base with you maybe in a week or two and see how you guys are going and follow up with any questions you might have, and we'll go from there.
Okay. Sounds good.
Thanks.
Thanks, guys.
Goodbye.
Enjoy the rest of your day.
Bye.